We are now going to take the data that we have about the years from 1979 to 2021 and the ice coverage in the Arctic Sea and actually come up with a line of best fit for that data, since we saw there was a pretty strong negative correlation existing there. So whenever we are going through that process of finding a line of best fit, we are going to use what's called linear regression. And so all that linear regression is really just the process of finding a line of best fit for some data. We'll use a method that's called the least squares regression, and you'll see a little bit later on why it's called the least squares regression. So to be able to come up with this line of best fit, of course, if you're just coming up with a line of best fit, you'll ultimately come up with an equation for a line, right? Like a y equals mx plus b. And so that right there is going to be the regression equation. In other words, the equation for the line of best fit. Now you'll notice that there's kind of that little hat on top of y right there, and that's to denote that this is the y value that corresponds to the line of best fit. It's what we denote as the predicted y value. To actually come up with the slope and the y-intercept corresponding to that regression equation, there's some math that goes on right there. But we're not going to worry about doing those calculations by hand. We'll just use technology to help us with those particular computations. So I will show in another clip how I did this regression on Desmos as well as on a graphing calculator. So just the result of me doing this on Desmos I have right here. So you can see in the graph the scatter plot of the data as well as the line that's going to be the one that we consider to be the best fit, at least by the least squares regression method. And so in this box right up here, that's the output that Desmos gave me in terms of this regression right here. And so what is the equation of the regression line is really what is the y equals mx plus b. This is the regression equation though. We want like y hat equals mx plus b. And then it tells you just in the results of Desmos that the m and the b are going to be those values. I'm just going to kind of round it because I don't have a lot of room here. So we'll say about negative 0.08 for the slope there, and then plus about we'll round it to 7.70 there for the equation of the regression line. And then over here, what is the correlation coefficient? So that's the R value, right, which tells you the direction and the strength of your correlation. So that is also given to us. You'll note that Desmos does give output of what R is, and then also what R times R is R squared. We want just R for a correlation coefficient, so it turns out that negative 0.8908 is the correlation coefficient for the data, and that makes sense because we've got a negative correlation, which corresponds to the fact that the linear association is negative, got a negative slope, and then also the 0.89 is, or the negative 0.89 is very close to -1, which indicates this is very strong, right? So yeah, the interpret its meaning in context is to mean that, yeah, there's a very strong negative linear correlation going on right here between the year and the ice coverage overall. We're now going to take this line of best fit, or this regression equation that we found, and make some predictions using this, because based on this pattern that we kind of see going on here, we might be able to say that, well, if this pattern continues, then in the future, what might the ice coverage be? Or maybe even make some predictions about the past if this pattern has even developed in the past. And so first of all here, we want to try to use the regression equation that we came up with, the line of best fit, to make a prediction as to how much ice cover there will be in the Arctic Sea in September of 2050. So recall that y is the ice coverage, right? That's what it's representing, and then x is representing the year, but it's actually the number of years since 1979. And so since we want to figure out for 2050, I do want to plug in, but like I want the number of years since. And so I believe that would be 71 years since this is 71 years later. So then we'd have to plug in a 71 for x here. So in so doing, then we would come up with the product of negative 0.08 and 71, and then add 7.7. So our result of that is going to be 2.02. And so, yeah, we would expect in 2050 that we would get 2.202, but that's really going to correspond to square kilometers, actually millions of square kilometers of ice coverage in 2050. And that's significantly less than the data we're seeing in the table, because like the least it ever got to was around 4 or so. So that's like half. In 2014, then, you just have to figure out the number of years since 1979. So since 1979, that'd be 21 plus 14, so that'd be 35 years since. So you just have to substitute a 35 in for the number of years since in that case. And that comes out to be about 4.9 million square kilometers of ice coverage there. And then finally in 1966, we could also make a prediction. So in terms of number of years since 1979, it's not really since because it's before. So it's actually going to be like, what, 13 years before? So you'd have to plug in like a negative 13, I guess, in for X to make that particular prediction. So, and then evaluating that, we come up with about 8.008 million square kilometers for a prediction using that line of best fit. Whenever we're making predictions with data, there are two different types of predictions that we can be making, one of which is called an interpolation and the other of which is an extrapolation. So whenever we're interpolating with our data, we are making a prediction that is within the range of the data that you have in your data set, whereas an extrapolation is going to be making a prediction but using data outside the range or the realm. So basically, we made 3 predictions just above in 2050, 2014, and 1966. So any prediction that would be considered an interpolation would be really using the data that we had given, which was between the years of 1979 and 2021. So actually, the prediction that we made here in 2014 would be an interpolation because that was within this data set that we had. And so an interpolation that we made was when we predicted for the year 2014. But otherwise, in the other couple examples, we made a prediction for 1966 and 2050, which was outside of the range of 1971 2021. So an extrapolation that we made happened in the 1966 prediction as well as in the 2050 prediction.